Welcome to OpenCV weekly webinar. And today we have with us Joseph Nelson, who is the CEO and founder of Roboflow. And Roboflow is also a silver member of OpenCV. They support our community. So thank you so much, Joseph, for being so generous over the years, and also your style of interacting with the community. The value you provide to the community is awesome. So we are very, very happy to have you on our webinar. Every time you are here, I mean, those shows are very popular. Not only on the live version, but also the YouTube version. People love what you have to say.
I really appreciate that. Yeah, it's a lot of fun. You all make for a great show. The audience continues to grow. And as I think I said to Phil last time, we'll continue to make it fun, just as always.
That's great. And we also have Phil Nelson on the show. The two Nelsons are not related.
Much like Buster and Babs Bunny, we are of no relation. That one's for the 90s kids out there. Yeah, welcome back to OpenCV Weekly Webinar, everybody. If this is your first time joining us, there are a couple of things you should know. One is that we do Zoom Q&A from you in the audience here. You on LinkedIn this week will probably not get to participate in the Q&A, but maybe next week. If you're in here on Zoom, please use the Zoom Q&A functionality to ask your question at any time during the webinar, and we'll do our best to answer as many as we can at the end of the webinar, or if it makes contextual sense, we'll ask it during the show. Also, we'll be doing a giveaway of, Satya, would you like to tell them what they'll win with our trivia giveaway this week?
Do we have a giveaway from Roboflow?
Yeah, we have our standard giveaway of a few things. One is free GPU credits for those that build and operate with Roboflow, which GPU increasingly hard to get access to. And then also we have Roboflow swag packs. I do have to note that those have to be shipped within the US, but we'll find the right sort of winners to get to for both those prizes.
Appreciate it. Thank you so much. Yeah, and so that'll be given away to whoever answers our trivia question, which will be after the presentation here. So stick around; you won't want to miss that.
So yeah, and the presentation today is very interesting. Joseph is going to tell us about deployment techniques for the edge. This is actually not trivial. A lot of people struggle with this. They train a model. Usually that's the simple part, especially if you're doing simple things like object detection or image classification. You can train it very easily using Keras or PyTorch, but then starts the difficult part, right? You try to take this model to the edge and it is slow. It doesn't work. You cannot get it. You don't have all the components in place. So this session will teach you a lot about how to do this deployment easily. So Joseph, take it from here.
Happy to. Yeah, looking forward to today's conversation. I'll share my screen for starters.
Yeah.
And as usual, we'll make today be both a mix of education and interactive content. So the topic today is talking about deploying. Now we titled it Getting Edgy, right? Because we can deploy to the edge. But I think we're also talking through a number of deployment techniques, and we'll walk through ways to get computer vision models into production, the benefits and disadvantages of a couple of those ways, and tips that are generally useful across each of those techniques. So as always, it's a pleasure to be here, and I'm looking forward to talking through some of the options. Of course, at OpenCV, you all are experts with partnership with Luxonis and the OpenCV AI Kit, the Oak devices, which I like to think of as like the Raspberry Pi for computer vision. We have tons and tons of folks out there that build with Roboflow and with Oak, making all kinds of fun techniques and tools. And so we'll talk about those as well. Right off the get-go here, I did include a slide that introduced at least Satya and myself. Phil, of course, is our fearless moderator and an essential part of ensuring the success of today's conversations. Though for better or for worse, you'll mostly hear from Satya and myself as we go through the content today. And as Satya mentioned, I'm the CEO at Roboflow, and Satya is the OpenCV CEO. Phil, it looked like you wanted to come off mute there for a moment too. Please chime in.
I'm biting my tongue. I'm trying to stay civil. I know that we're live on LinkedIn. I'm kidding.
We'll get your bobbing face in here next time. But yeah, I mean, I think it's always helpful to provide a little bit of context on both OpenCV and what Roboflow are. So Tia or Phil, I'll let you voice over a little bit about OpenCV. Of course, most of the folks I'm sure know you, but they might not know the scale and breadth of the impact that the OpenCV library has had over a couple of decades.
Right, and especially, we also have people who are your audience, Roboflow audience, who may not be familiar with. So OpenCV is the biggest computer vision library in the world. We have been around for 20 years, more than 20 years, 21 years actually. It started in the year 2000. It was open sourced by Intel. And a lot of people don't know that OpenCV was also part of the DARPA Grand Challenge in the year 2005, when Stanley, the car that won the DARPA Grand Challenge in 2005, it was the first car that completed the Grand Challenge and won the prize. It's in Smithsonian Museum now. That car internally was using OpenCV as the computer vision library. It was using a whole bunch of other sensors also, but the computer vision library was OpenCV. And since the last few years, let's say the last 3 years, we have been growing beyond the library. So OpenCV has courses. OpenCV also has OpenCV AI Kit Oak, which is a series of smart cameras which can do neural inference on the device itself. And some of the variants can also do depth estimation on the device itself in real time. And as part of that expansion, we also reached out to people who have similar values. And that's where Roboflow came in. We saw what Roboflow was doing, and we invited them to be our silver partner, which supports the OpenCV community. It supports the development of the library, etc. So yeah, that's a short bit about OpenCV.
I think what's really impressive about OpenCV is just the longevity and utility of the library, right? I mean, well before deep learning and machine learning came to image technology and image processing, OpenCV was there with some of the more traditional techniques and has continued to evolve and stay with the times as increasingly there's newer technologies. And I think because of that, because of its developer-centric approach, which we really agree with as well at Roboflow, it allows almost having the building blocks. So we have a lot of users that will build tools and technologies with Roboflow and with OpenCV's libraries. So they'll do machine learning to identify a specific portion of the image, but then they'll do, say, thresholding or a technique like this of the dozens of algorithms that are out of the box in the OpenCV library as post-processing of those detections. And so it's been a really impressive and continued growth. And as you mentioned, we've even actually now had some customers that have built with OpenCV consulting and with Roboflow, which has been cool to see too.
Nice, yeah. And also, talking about the longevity, we recently in one of the top conferences in computer vision, the orb feature, there are these features, SIFT, SURF, and orb, which are used for feature matching. It won an award for the big impact, some big impact award that over the last few years, it had the biggest impact on in the industry. And that feature was actually developed by the OpenCV team. Gary Bradsky is on that paper, Ethan Rubley, who is closely associated with OpenCV. He was the primary author, etc. So yeah, I mean, there are a lot of algorithms, etc., that have been around, developed through OpenCV and part of OpenCV.
I'd like to note that this is the second week in a row that we've talked about an orb of some kind, and I am 100% down with that.
That's great. Yeah, so lots of respect, and for the same reasons, we're eager to be supporters of continued open source and implementation of computer vision for the masses. At Roboflow, you can think of us kind of like the building blocks that developers use to bring computer vision into their products. When you want to use computer vision within a product, it requires a relatively wide array of tools, everything from how to handle image collection of video and imagery, how to organize that imagery and video for identification of what should be annotated actually annotating data and having models and automated annotation of that data, or even third-party services that annotate data for you, pre-processing and augmentation to increase data set size and variability, training of those models, whether you want to use open source models that Roboflow is interoperable and integrates with, like say the YOLO family of models are quite common in computer vision land. And then also deploying things to a wide array of techniques to the edge, as we'll talk about in great depth today, but also to microservices, whether that's APIs, mobile devices, or even directly in the web browser. And then critically, I think the thing that Roboflow users really get a lot of value from is closing the active learning loop. So once you have a process by which you can create and deploy a model, it's essential that that model continues to learn from the environment in which you're operating. And precisely because the images we might have in our training set are not representative of the full world around us, it's key that we're able to continuously identify and improve and expand the scope of what those models can accomplish. And so Roboflow kind of ends up being this machine learning operations tool that orchestrates the ability of, kind of running that ongoing loop, where users will plug in different parts along the way, right? So they might have their own kind of open source model that they train on. They might have a different way of collecting imagery. They might be using some OpenCV algorithms for doing like thresholding or edge detection. And it's that interoperability that, is really part of our ethos, being created and run by developers for other developers. And because of that, over 50,000 engineers have built with Roboflow, including those from over half the Fortune 100. We count customers like Walmart and Cardinal Health among those that build with Roboflow, and continue to see the enterprise adopt and use these tools in impressive ways. So on the right-hand side, I kind of have you can imagine it's like animated in a Star Wars way. I toyed with that, but it was a little too distracting. So I just have the floating words on the right-hand side of the slide, but you can use your imagination to pretend that they're further going out into distant space, but all sorts of different ways that people have built with Roboflow. Things like gas leak detection, like determining if there's crude oil releases or highly volatile liquids, tracking pitches. I could use that. I'm pretty lousy on the pitcher's mound. Roof damage estimation. So if you have a drone that flies over top of homes and you identify, if there's hail damage or if there's an insurance claim to be made. Satellite imagery analysis, everything from counting swimming pools to determining if there's given structures. Tennis ball tracking. We actually, Roboflow is used at Wimbledon each year for doing things like tracking the tennis ball as it comes across the court, and does improved camera operations. Smart retail checkout technologies, measuring fish. It's kind of funny, the number of developers that are working on fish problems is insanely high. That seems to be everything from identifying fish to tracking them to seeing their speed to ensuring that there's legal fishing that's happening. Public transit occupancy counting, right? So knowing which bus routes or train routes are most common, or knowing which parking spaces are being most utilized, is all an intelligent image analysis problem. Identifying plant health. So everything from knowing not just the counts of, say, the number of berries that are growing, but the stage of those berries and what yields farmers could expect. Cataloging inventory and counting things underneath microscopic cells. Truly, we like to joke that the use cases that we've seen for computer vision are everything from under a microscope to outside a telescope. And it's true, everything in between that is in the observable world.
I had a similar, I like giving ranges for our consulting services. I like to give this range that we actually work with. At one point, we worked with a company that analyzed horse feces for parasites, right? So that's one range. And on the other side, we worked with a company that did high-end fashion, and we had to identify high-end, fashion handbags. So that was the range, but that's another range.
Wow, so you actually almost literally had telling ship from Shinola.
I had never used that expression. Now I can. Great.
That's great. Recently on Roboflow, we actually had a curious hacker, and they put out a YouTube video, and I'll be sure that we include it in the email follow-up, but their cat during the pandemic, they were concerned that he wasn't getting enough exercise, right? And so, you can point a laser pointer and a cat will chase it. Well, he bought one of these kind of toy robotic arms and then built a model or collected some data of his cat and then annotated it with Roboflow and then built a model and deployed it to track where his cat is. And then he did just a very standard rule-based method that wherever the cat is, add basically like 5 feet and then shine a laser pointer there. And so then this robotic arm is just pointing the laser all around and his cat's jumping around and doing exercise. And so at Roboflow, if you need a cat exercise machinery, we're the tool.
I was actually surprised, Joseph, we cannot obviously mention, but you have some very big clients, Fortune 500 companies using this tool, which was surprising. I always thought that Roboflow was a tool for startups and, companies that are, less than 1,000 people, right? That's the sweet spot. But I was pleasantly surprised to know that, there are a bunch of Fortune 500 companies that are using your tool, at least different groups in these companies, which is a very positive sign. Speaks a lot about, because these companies can build their own. They are not building their own and coming to Roboflow, which is great.
Yeah, what's interesting is that the same types of problems, in fact, that a individual hobbyist might face, a large enterprise faces. Like, which images do I annotate, or how do I get my model deployed in a reliable way? And I think the thing that startups are usually quicker to realize, that larger companies are coming to conclusions of as well, is focusing your resources on where you have comparative advantage is the most efficient use of those resources. So for example, right, if you have teams of developers and those developers work at, we'll say a energy company, the thesis of that business is to ensure the safe, reliable, efficient, cost-effective delivery of, say, crude oil or natural gas or highly volatile liquids. And so using engineers' time for reinventing the wheel on building your own annotation tool or building your own MLOps pipeline, it's for the same reason that we don't build our own data centers, right? We use the best in class and then focus on the part of the value chain that we can add value to. And I think that for that reason, there are companies whom, vision is their core innovation, right? So Tesla is a famous example. Karpathy's team has built, they built their own chips, let alone their own models and their own tooling and their own everything along the stack. But what I think was interesting is that, not every company needs to reinvent the full wheel or the full car, if you will, to be able to use computer vision in really impressive and value driving use cases. And I think as companies continue to realize that, they're getting to value more quickly by using, I kind of think about it like the Lego bricks, right? Use the Lego bricks that allow you to build your house more quickly. And that's why I think developers are such a impressive group of people, because they're creative. There's no limits, whether that's finding horse poop in your example or finding cat exercise in my example, but also curious too. And so providing engineers with the tooling to get to value faster, I think it's kind of a win-win. And we're continuing to see that with the adoption just across enterprises as much as startups and hobbyists and students. I think that's a good segue to how we kind of think about the deployment portion of what are we talking about today specifically? I mean, so we talked at a high level of the machine learning operations pipeline is, there's everything from collection and organizing and labeling and processing, training, deploying, and displaying. We're going to zoom in on perhaps the most fun icon, the rocket icon of deploying and running models successfully. And the things we're going to talk about today are not this is how you need to do it with Roboflow. No, we're going to talk more generally. When you're deploying a model, what does that mean? Where can you deploy it? What are considerations to bear in mind? What are best practices? What are tools that allow you to do that? Who has the best hardware along the way? And of course, I'll provide commentary of the tools and best practices we've seen from users, but by no means is this something that says, oh, this is only the products that are within the Roboflow suite of products. In fact, more broadly, I think computer vision's democratization and usage is far beyond any single company. And so the more we can empower its use and allow people to be aware of the technologies that are at their disposal, the better. And so we're going to zoom in on that deployment bubble in a moment. But Satya, I'll let if you had any thoughts or commentary before we zoom in.
Well, I was just smiling because those thoughts are very similar to mine. Whenever we are talking about, computer vision in general, the pie is growing and we have to contribute to the growth of the pie, right? Not try to, get the biggest chunk of the existing pie. You make the pie bigger, there is enough for everybody.
Exactly. Awesome. So let's talk about deployment. I very creatively call this slide deployment. Let's talk about it. So I think there's kind of 4 things to chat about today. I mean, what is deployment? I think folks probably on this call have a good understanding of it, but we can give it a really nice bow tie definition. Then we'll talk about the ways in which we can deploy models. We'll talk about what success looks like and common pitfalls to avoid, and then we'll do some audience Q&A. I suspect most of our time will be spent on number 2 here of like the different ways you can deploy, comparing and contrasting. What does it mean to go to the edge? What are given hardware decisions? But of course, as is common, this is sort of a loose agenda, and the questions that we get and the conversation that Satya, Phil, and I have will drive where we spend the most time. When we talk about deployment, I think the way that I kind of think about it is it's basically the process by which we use computer vision models in production, right? At its core, it's like you've got a model. Now, deployment means you're not in the Jupyter notebook anymore. You want to have it out in a way that you can use wherever you want to use it. And that might be microservices via APIs. It might be embedding it on the edge on mobile devices. It might be running it directly in the browser, or anything in between. One idea that I really want to hit on before passing it to Satya as well is that when we talk about deployment in a software engineering context, it's actually a bit different than when we talk about it in the machine learning context. In the software engineering context, you kind of you deploy a new release of software and it goes through your CI/CD pipeline to ensure that it passes all tests, and then the software is out and live. And deploy in this context is kind of like a one-time. I mean, you're going to deploy multiple features, but you kind of like it's a moment in time. In computer vision and machine learning more broadly, deployment is a bit more like setting up a system to run. And it's less like, oh, okay, I'm going to push this button and I'm done. It's more like, what's the compute that's going to power my model in an ongoing way? And I think that's an important cognitive switch that is required, because it begs the question of what level of compute do you need? Where is that model going to run? What sort of throughput do you need? And it's much less like a click it and forget it sort of interaction. It's much more a, how are we going to create a system and include the considerations for computation and accuracy and redeployment that allows us to be successful. So my like crude analogy I've been working with, I'll workshop this and see if you all like it, is I kind of think about it less like a CI/CD pipeline and more like maybe like cybersecurity software or like CDN software and CDN products that enable you to have your model, or in this context, your web page, run at the edge and cache your images and things like that. And it's an optimization to be made in that context rather than a one-time, push the button, deploy the new push of software. So I don't know. I'd welcome your thoughts here, Satya, like a mental model around this.
Yeah, I agree. So it's quite different from regular software development deployment, because traditionally what we used to do is you are developing a software, right? It's in your local environment. The environment changes, but the code doesn't change, right? The code is the same when you deploy it. It is just a different environment, right? It needs to take care of that, and those things can be handled if you have a good continuous deployment pipeline. In machine learning, though, there is one level extra added complexity. The model you train is not the model you deploy, right? And I'll give you an example. We built a background subtractor for our own internal as a product, and then a client came to us. They wanted to license this, and which is fine. We have this model, but which runs great. But then they wanted it to run on the CPUs. Okay, so we have a CPU version. That's one deployment. They wanted it to run in a browser. So we have a WebRT-based deployment. So that's the second one. They wanted it to run on an edge device. So we have an OpenVINO-based some optimizations we did, right? So you can see that the model does, and these models are not going to give you the exact same results. You have to ensure that they are close enough, and the deployment environment provides different, they are all different environments, and the goals are different. In some cases, accuracy is paramount, right? When you're running on the server, they say that, okay, use as many resources as you want, use the GPU if you want, but give us very accurate results. On the browser, for example, it's like, okay, the accuracy doesn't matter as much, but you have to make it at least 15 to 20 frames a second so that you don't see the lag as much. So you can see that we started with a trained model, but the deployment scenarios were very, very different, and we have to customize the model itself for different scenarios. In traditional software deployment, you don't think as much, you don't spend as much time on deployment. You spend time on the initial setup, but in machine learning, this is a big deal. You have to allocate a lot of time for this piece. So those are my 2 cents.
I think it's a really, really good salient example of calling out, you have a model that does something, in your case, background subtraction, but where you're using that model dictates what and how that model makes its way to production. In other words, it's not like those same exact layers in that same exact architecture. And so like people will commonly ask, like PyTorch, TensorFlow, Darknet, all these sorts of things. And actually, it kind of like, the answer is it will depend on where you're using the model. Like if you need a really high throughput on NVIDIA devices, you might want to optimize your model with TensorRT. If you're satiated with, a near real-time performance and you don't need to be truly like bleeding edge, then just deploying it as it is from TensorFlow or PyTorch will work in the same environment. And I think that you bring up the way of framing it of the model running or the model being trained is distinct from the actual same exact architecture that gets deployed is a good way to highlight that. So there's a tactical difference. And I think, which is why, like when solving a computer vision problem, we need to ask ourselves, where do we think we want to run the model early on in the process? Because that will frame some of the decisions that we make along the way. And the other thing I think to call out is, so there's that kind of that like tactical element. The other thing I think to call out is we want to include from day 0, how are we going to continue to collect images of the failure cases, or even of expanding the scope of what our model is doing. Let's say we have a model that's like, I don't know, texts us whenever there's a bird at our bird feeder. But then over time, we want to actually get texts when it's a cardinal versus a robin versus a more maybe unique bird. And that requires continuing to collect images of each of those bird species and then labeling with a bit more specificity and then redeploying that model, then collecting new images of all the various birds that might be appearing at our neighborhood bird feeder. And so in this context, it's not just, model getting better, but it's like, how are we continuing to sample and improve and deploy? And I think that this is often the difference of like a production grade system and kind of like a one-off, is that like a one-off system, like kind of like hobbyist projects, or I kind of like to joke, sometimes you end up with like these, Rube Goldberg machines. It's like, you put in like the quarter, it rolls down, it hits like an egg, the egg rolls and falls and splats. That's enough weight to cause like a ruler to go up. And pretty soon all the way at the end, you have this like winding series of things that result with, I don't know, like toast coming out of the toaster or something like this. Right. But sometimes what I think deployment pipelines kind of end up looking like is that like, oh yeah, of course. So you train the model, and then once the model gets trained, just download it, and then also go over here to this random script we have that'll convert it to OpenVINO. But then once it's in OpenVINO, be sure you come back to this other script that we had that John wrote before John left. But don't worry, it still works because John had wrote it and John was a good engineer. And then you put it back into here, and then it works, easy. And so it's like thinking about having a robust system is also important for this interaction.
Right. One last thing is, in traditional software, when you deploy, you could say that, oh, I have done enough testing, etc. So the deployment is not always set up to receive feedback, right? And it's not necessary that feedback comes through. But in case of computer vision models, it is almost necessary that the data you're getting, the model, let's say it's running in the field, that needs to make it back into improving the system, right? So that data that you're looking at from the field has to, you have to architect your system so that you get the data back into your system from the field so that you can improve it, right? That's crucial. It's almost not like an option, right? And many companies do that, but I feel that it is crucial because, you have to train the model based on the data that's coming from the field. And it's a continuous improvement process.
Totally. Yeah. So I think that's a pretty good overview of deployment and like what deployment isn't and common misconceptions. Let's dive into the ways that we can deploy things. Now, this isn't necessarily comprehensive, to be clear. It's kind of like an example of some of the most common ways to deploy models. And this will be ever evolving of different ways, different hardware, different configurations. Now, that said, I think that there's kind of like 4 common ways that we see deployment happening. And I wouldn't get too hung up on the taxonomy being perfectly correct of separating between these. I would more think about them as options and menu of options. And so there's things like deploying a model via a web service and using it via API. So for example, a simple call and response. The model exists on a remote server. You send up an image or send a video, you get back JSON of those detections. On edge hardware, and that's the getting edgy. We'll spend a lot of time discussing that on today's conversation. On mobile devices, I broke that category out, but it's arguably just another type of edge, right? I mean, a mobile device is an edge device at the end of the day, but there are some different considerations. So I thought it'd be interesting to call out as an option. And then directly in the browser, this is, I think, an emerging way to deploy models that we've seen a lot of creative use cases, and it'd be important to call out as an option. Now, deployment isn't one size fits all, right? I mean, one of these methods is better in some circumstances than others. Like if you have a website, for example, that we'll say, let's say that you're building the website that might be relevant to what Satya was mentioning around, people that are selling used goods, and you want to know if that used good is legitimate or not. Well, in this context, you're building for a web service. So a user uploads an image. It actually would be quite convenient to have a web API that you just call and say, what's the probability that this is a true handbag or a counterfeit handbag? And that might be an example where an API works really well. Now let's pretend that you have people that are working, we'll say at like a secondhand retail store, and they have this same model of determining fakes from trues of purses on their phone. That might be a place where you deploy that model to the edge, and you point your phone at the purse, and the model's running completely on the phone. There's no call and response, and it's telling you, fake purse or real purse. And so hopefully this gives some context of like, it depends on the problem of how you want the models be used in your service as to which of these techniques will make most sense.
Yeah, web service is very important. Using AI as web service is very useful when the platform is diverse, right? When you cannot control the platforms and the system doesn't need to be really real time. So like if you're dealing with images, etc., a web service will do just fine. And it is the easiest form of deployment as well in some sense. Very good choice. If you're a one-person team, don't even try to do, optimize things for separate hardware. Use a web-based service, and that's a legitimate way to do. Once you get, in some cases that's all you have to do. But suppose you feel that the performance is not as good, etc. Still, you should start with the web API, and then once you have traction for your product, then you can go and customize it, right?
Totally. Yeah, and I think that that's a really good point. Is that where you start, you might first deploy via web API because it's simple and easy. So if we go back to the Purse mobile app, let's say that you are the secondhand retailer and you have this product that tells you if something's real or fake as a purse, and you have it in the web product, but you don't have it on the mobile app yet. Well, you could still create a mobile app that the user says, capture photo, and that photo gets sent up and comes back, right? That would still work. And then if you wanted to optimize it, so it processes real time, from the video camera live on the edge, well then yes, you would have to do a different deployment method. And so I think you bring up a really good point that this can be a, you can keep it simple to get to value, right? Because we would still be getting value from knowing if it's a real or fake purse. Even if the user interaction could be made a little bit more seamless, there is still value in knowing point to click, image gets sent up, image comes back, real purse. I'm going to stock it.
Yeah, there is this thing called in software engineering, we call it, premature optimization. So especially for startups, it's crucial that you first establish whether the product has legs or not, right? And for MVPs, this kind of interface is great. because it doesn't consume a lot of time. You establish value by saying that, okay, here's a service. It can be better, but this is good enough. Try it out. And if you see enough people using it, then you can do the optimizations.
Perfect summary. So yeah, I think an example of, so we talked quite a bit about like web services and deploying via an API, but basically what we mean here is, call response. You could use video or individual images, and you call that API. I mean, an example like Facebook, for example, a web service that runs many APIs and images and helps you know when you need to tag your friends because they saw in an image a face and said, who is this? And you can add a tag to that image. I thought it might be fun to do a little bit of live example here. If we all want to buckle up, get some good grins, and we'll see what breaks when I do things live. So let me
brave live deployment. Do
always.
it.
So I'm gonna stop my screen share and then reshare my screen here to see the full screen, because then you can see my terminal as well. Okay. So what I'm going to do is I'm going to take a screenshot of our faces, of Phil, Satya, and me. And Phil, I'm going to pick on you. If you want to make like a funny face, we'll see if it'll find like your funny. Yeah, wonderful. Wonderful. Okay, so I just captured. Oh, whoops! I got to redo it. I'm sorry. I don't know how to use screenshot. Yeah, there we go. Okay, perfect. So on my desktop, I have that image. Yeah, so I have a folder called All the Answers, and I have this screenshot. I'm gonna go to my desktop, and I'm gonna actually go ahead and rename it to, I don't know, photo.jpg is what it's gonna call.
Still the hardest problem in computers, naming stuff.
Yeah, you saw me freeze there. I was like, what do I do it? Photo.png is what it's gonna be called. And then I separately have a model here that finds faces. And this model does all right. I mean, it's trained on about 2,000 images. And so I have this use curl command, and I'm going to have to, I will be erasing my API key for all you folks out there after this, but I will be showing my API key momentarily for the purposes of doing this curl command. And so this model exists and it's live. And what this model does is it just finds faces, right? And so we actually trained it on images of some folks with a team that had masks, some public data sets of folks that were wearing bicycle helmets, and all those sorts of things, right? So you get an idea of what's going on in this data set. So 847 examples, a little under 2,000 annotations, diverse set and size of images. So I'm gonna go to my terminal over here. All right, and I'm gonna go ahead and your image.ping, I'm gonna actually make that be photo.png. And so I'm base 64 encoding that image, and then I'm passing it up and doing a curl command directly to this model with my API key. And then boom, it worked. I get back these predictions here. And these predictions are in JSON of the XY coordinates. That's not as exciting as being able to see the results. So I'm going to actually go over here and click example web app, which does the same exact thing. It calls the API, but it's also going to visualize the results for me, which makes debugging nice. So here's the moment of truth. Do we find Phil's silly face? So here's the photo. Punch it in. Confidence 40%. Let's go ahead and run inference. Hey,
it got me. I'll be damned.
Found you.
I mean, what do you mean? That's just what my face looks like.
And I get the JSON here as well, right? So the JSON of each of these, on someone's face, it's 86% confident. And the other one's about 50% confident. So cool. So that's just an example, right? Of we just ran the model via API and quick call response and got it back. So
if anybody wants free use of Joseph's API key, it probably got about 20 minutes. So make it quick.
That's a fun challenge.
Yeah, I mean, you're hiring, right?
We are hiring. Yeah, which engineer can rack up our cloud build fastest? Yeah, so that's kind of just a simple example of, call response, use the API, and you get back JSON, right? And with that JSON, you can do things like, based on the confidence level, like for example, that image, I might actually send back to my training set because I want maybe my face detection confidence to only be like 80% plus. And the fact that I had a couple of 50% there, I'm like, oh, I need more of Phil's silly faces for this to work better. All right, so it's time. We should talk about edge deployment. When I looked for edgy meme, I got some suspect results. And so this is where I landed of the edgiest meme that I felt comfortable including in today's presentation.
Yeah, thanks for
Joseph,
following
it
your
may
best
be
judgment there.
useful for, because we have a lot of beginners also in this webinar. Can you just define edge so that people know what an edge device, or what do we mean by edge deployment?
Exactly. So yes, so deploying to the edge. When we say deploy to the edge, we mean basically deploying to a piece of hardware that exists out in the field, I like to say. So typically a GPU, and that GPU runs the model right then and there on site without sending the data anywhere else. And so at the edge means the model is running in a self-contained way on a specific piece of hardware for the purposes of our application. So an example of one of those pieces of hardware might be in an NVIDIA Jetson. So on the left-hand side, I have an NVIDIA Jetson picture. And on the right-hand side, I have the Luxonis Oak, the OpenCV AI kit. This one is the Oak D. And then on front, I just have like an example of a little Docker bubble and the Roboflow logo, because we'll talk a little bit about why that is helpful in this context. But the broad idea here is deploying to the edge is when you want to have a model that runs perhaps offline, so no internet connectivity. You want to have it run real time, so like on a video feed. And with less frequency, you send data back to the cloud. Maybe there's some examples where you are extremely limited and can't send any back, but remember from our prior discussion, it's always useful to have the ability to continue to improve the model by some degree. And also, even if we're not sending data back, it's helpful to monitor model health, right? So knowing if like an edge device is live, is it on or off? Is it dead or alive? Is it successfully making detections? Even if we're not doing model improvement. And of course, we'll want internet connectivity to say, like ping the model and say, hey, are you awake? Are you alive? Are you making detections? And then you get back, yes, and these are the detections that I'm making on a regular basis. So edge deployment is really common in computer vision. I mean, let's give some places where it's going to be useful. There's things, for example, like if you're working on an application in agriculture, you might have a model that's running completely in a disconnected field, and it's doing things like identifying weeds versus crops. You might have a model that's running on a drone, and that drone doesn't necessarily have internet connectivity, but when it sees things from below, it wants to capture images or do some sort of business logic with the data that it sees. We have customers, actually one of the world's largest manufacturers deploys with Roboflow into their factories. And inside those factories, they have a combination of hardware that runs offline on their own intranet, not making any outside connectivity. And that helps verify that when the goods that they're producing come off the assembly line, they're of the quality they want. It doesn't result in any sort of malformed things in product that goes to end customers. And so there's a number of use cases where edge deployment can make sense. Now, of course, there are disadvantages too. Precisely because the model is running in a more offline environment, it might be more difficult to monitor model health. Another example is that it actually might be quite challenging to do development for the edge, which is why earlier Satya and I were mentioning it can be useful to deploy a model to like the cloud, like an example I just gave, right? Where we had our faces and then like I just threw it at an API and saw, was it working? To do that same demo, I'd have to like go deploy it to my Oak and then like call the Oak and then see the results on the Oak, which, isn't too hard or anything, but it's more steps than might be necessary at the point that I'm at in my development process. And then of course, edge hardware just kind of introduces its own complexity because the hardware on the edge could fail. You have to purchase that hardware. You have to manage that hardware. And those are some things to bear in mind that might be complex systems. So that's a high level overview of what edge deployment is. Now we should shift to talking about how do we get high throughput? How do we get the ability for things to run consistently? But I'll toss it back to Satya if there's any sort of thoughts you want to add here on Edge.
Just to add to what you said, one of the big reasons, in addition to what you said, one other big reason to use Edge is privacy, that people do not want their photos to be uploaded to the cloud. So they may, the Edge device can do the processing and lock no photos leave the Edge device. You can actually configure some of these devices that no photos would ever leave the device. So that's a big one. And so performance, privacy reasons, and obviously connectivity. When you don't have connectivity, it's very useful. And the other thing with Edge device, the downside is also that you have to have a way of updating the model. Even when it is connected, right, it is much more difficult than updating a web server, for example, that over the wire, when you're trying to update the model, or there's always this, what happens when the update fails and things like that. So it is much more complicated when you're using an Edge device.
The failure modes are myriad. Like there are many more ways it can go wrong.
Yeah.
Speaking of which, we are button up against 9:50 a.m. Do we want to pause briefly and do our trivia giveaway?
Yeah, that's a perfect time.
Joseph, would you mind unsharing your screen real quick?
Yeah.
Cool. So for those of you who have never joined us before, or if you just need a reminder, we do a giveaway here. This week, we will be giving away a Roboflow gift pack. Thanks so much to Roboflow for their generosity. I'm going to ask a trivia question, and you're going to answer it in the Zoom chat window. For those of you watching on LinkedIn, don't answer in the comments. It's not going to do you any good. Sorry. We'll try to come up with some way to include you as well. But the first person to answer correctly in the Zoom chat window, this trivia question I'm about to ask, will win some Roboflow credits, and if they're in the US, also a swag bag. So thanks again, Roboflow. Get ready to answer. Earlier in the webinar, we discussed a specific feature detection method that is part of the OpenCV library. What is the 3-letter name of that method?
All
right, we got it. We got some good ones here. Partha, you won too recently. I can't give this one to you. It's like Krishna Mohan Chini is the first one I see after Partha, which is the answer is orb.
Wow. Hi, Krishna. Krishna used to work with us.
Oh, really?
Back.
Well,
yeah.
No, congratulations, Krishna. Please send one email to phil@opencv.org, and we will make sure that you get your stuff. Go ahead and start up the presentation again, Joseph.
Yeah, absolutely. Cool. Let me re-screen share. So there's a couple other methods that we wanted to chat through. So we can do this pretty quickly and probably jump right back into Q&A. So Edge deployment, a couple of things that I want to kind of rapid fire mention about Edge deployment, and then we can move to mobile and web browser. On Edge deployment, getting high throughput, that is getting high frames per second, is often a key consideration. And that's based on the model size, as well as the hardware available to the model, right? So like a Luxonis Oak can often achieve about 30 frames per second when deployed. NVIDIA Jetsons come in different levels of style, or different levels of compute. There's Nano, Xavier, NX, and in that order of computation power, and the frames per second is going to differ based on which of those you're using. And so that's an important consideration. And there's optimizations to be made. So there's a number of frameworks that are available to optimize how models run on given frameworks. So for example, for Intel devices, you optimize models using a framework called OpenVINO. For NVIDIA devices, you optimize perhaps using TensorRT. For Luxonis Oak devices, which are based on Intel primitives, you do OpenCV or OpenVINO, and then go to the Depth AI framework that Luxonis maintains for deploying to Oak devices. And so there's these optimizations that can be made to ensure performance models. But again, like, while more is always better, the sufficient number that is required is usually best, right? So like, you can always eke out more frames per second perhaps, but it all comes back to the business logic of the problem you're tackling, of what throughput and frame rate is required to tackle our question in mind. I'm going to jump quickly to mobile devices. And I mean, it's mostly a style of edge. I called it out separately because there's different technologies. Like you can use Create ML, for example, which is kind of like a very lightweight, low code way of creating a ML model to deploy to iPhones. We have a tutorial here that will include an email follow-ups of like doing that. It's pretty fun. Brad goes out to the Omaha Aquarium, he snaps a bunch of photos, and then he puts it into Create ML and he deploys it back on an app that works at aquariums for fish identification. An example of this might be like a mobile bank app where you take a photo of a check and the check shows up in your bank account. That's doing machine learning, I think, at the edge. I don't think it's sending that anywhere else. And then the last one that I want to talk about is in browser. So this is interesting.
Can we go back?
Oh, yeah,
I just want to add one more thing to mobile. So for mobile people, who are new to computer vision may not realize that there are two reasons why it is. I'm glad that Joseph put it as a separate category. First of all, the computational power available on mobile devices is insane. Some of these are much more powerful than so an iPhone 13 Pro Max would probably be more powerful than a Chromebook. I don't know.
So Apple is now putting basically the same neural engine in their high-end Pro laptops that they're putting in the iPads and iPhones. Yeah.
Right. So that's one thing, that you do have a lot of computation available to you. And the second thing is that at least in iOS, there is a neural network, pre-trained neural network that comes with the operating system, right? So you have the same neural network on the watchOS, on macOS, on iOS, and it is possible to train this neural network, just the last few layers of this neural network, and create an object detector. If the problem is, not very complex, not very custom, you can create an object detector, image segmentation, etc., using this pre-trained model. So what are the benefits? The thing is that your neural network, while deployment, could be a few kilobytes, right, instead of megabytes or sometimes gigabytes. The reason is that you did not ship the entire neural network. You shipped only the last few layers of the neural network. The neural network is part of the operating system itself, right? So that benefit you get, it's inexpensive. The size of the app that you're building could be very tiny. It doesn't need to download a model. So that's one more thing I want.
And it's hella optimized as well for the metal.
Yeah.
Great callouts. Great callouts. Yeah, and then the last one to kind of chat about is web browser deployment. So this is different than API, because what happens in this context is the model actually loads entirely client side in a user's browser. By that I mean, on initial page load, everything that the model needs to run gets transferred to the user's session inside the browser that the page the user has loaded. And then from then on, there's actually no internet connectivity that's required for the model to continue to run. And it makes use of the local hardware that user has on their local machine. So we've done this with for example, Mac M1 versus older Macs, and you see difference in frame rate and performance. I thought it'd be kind of neat to show the same kind of face detection model in a webcam type way. So what's happening here is the page is loading, and it's a pretty big page to load because all of the model data needs to get sent to the edge or to the browser in this context. And then now the model is running completely inside my browser and not making any responses elsewhere. So it's kind of like an interesting hybrid of, you get the privacy element here. None of this data is getting sent back. You get the ability to build it into mobile apps. And we've seen a lot of innovative work with this of for example, folks building always on iPad apps at point of sale checkout systems, where the iPhone app is always running in the browser, and they get all the benefits of easy deploy to that edge. But yet all the privacy benefits and speed benefits of this kind of working. And we were talking earlier about privacy. The reason I'm showing this model actually is this is actually a privacy protecting model, because we have some users who are working on projects where they're not interested in faces. In fact, they're interested in products and goods, and to know what data they don't want to store in their servers, they have to find faces at the edge, black it out or blur it out, and then they can save those images, right? Which is kind of like a funny oxymoronic thing. You have to find the face to then black out the face to then send the image up to somewhere to do. And so this is a model that's completely free to use to just get up and going. And if you want to do like your own sorts of face blurring, perhaps you're like hacking your Nest camera and you don't want your friends' faces in the data set or whatever it is. But that's kind of like one of the deployment methods that I think is emergent and increasingly interesting that we're seeing across Roboflow use cases.
In fact, in traditional computer vision, there is OpenCV.js, which runs entirely on the browser. And there are some models available there which you can do on the browser. Inside the browser, you can use OpenCV. It's not the full-blown OpenCV, but many functions are there.
Exactly. Yeah, we have Roboflow.js for the same thing.
Oh, nice. Yeah.
Yeah. So I know we're coming up against time. This might be a good option to kind of turn to a few questions with just the final kind of tips slide live. Phil, I'll let you lead us.
Yeah, sure. So we've got a couple decent questions here. Joel Henry would like to know, is Roboflow HIPAA compliant? Is there a HIPAA compliant version of Roboflow for storing data that's compliant with government regulations with regards to health information?
Yes, great question. Yes, Cardinal Health is one of our customers. They're a Fortune 50 healthcare company, and to support their use cases and their data sets, we both had to ensure HIPAA compliance, and Roboflow has the ability to execute BAAs, business associates agreements, that a number of healthcare partners rely on for trusting and ensuring safety of their data. So Joel, feel free to shoot me an email direct for any deeper conversation. I'm just joseph@roboflow.com.
Cool. Yeah. I'm sure, I know that kind of stuff is a big pain. Like it's tedious to get that kind of certification. So it's cool that y'all have worked through that. Cepho would like to know, is there a way to easily store and annotate model inference results on Roboflow?
Yes. That's a great, let me just call it, that's a great question to ask. That's like exactly the question you want to be thinking about is, I've got my model, it's running, can I then continue to improve? The answer is yes. So Roboflow has a pip package that users will incorporate into their applications, and then they'll send images back. So when the model is running at the edge, for example, let's say it's running on Alexanis Oak, and you get a detection of Phil's silly face that's too low confidence, and we say, oh, this is an image that we need. You then
for what it's worth, Phil's silly face is very low confidence.
Then you get Phil's silly face, and then you use the Roboflow pip package to send the image back to your Roboflow project, where you can do re-annotation of those low confidence predictions. So this is something that I think is a great question to ask, and something that I think a lot of folks should be thinking about.
Yeah, thanks for that. Partha had a question that I think will be interesting for both Satya and Joseph. We've talked a lot about different hardware, and there's so much different edge hardware, especially these days, like the Oak devices and the Jetson. There's even more, even some of the OpenMV cameras, I think, do inference and stuff now. How do you think about optimizing specific models for the specific hardware? Because they really do have their own deep optimizations that can be the difference between a model being performant and a model being really sluggish.
I'll let Satya speak first, and then I'm happy to comment on it because I've spoken a lot.
Yeah, we have never worked with OpenMV, but so I don't know about that.
Let me interrupt. Do you mind unsharing your screen, Joseph, real quick?
Yeah. So we haven't. I've personally not worked with OpenMV myself, but with other platforms, we use the tools that, first of all, when you're building for the edge, you start with a model that is designed for the edge. Let's say a mobile version, MobileNet or something like that, instead of, let's say, Inception v3, right? So you start with a model which is already small and designed for the edge. And then you use the tools provided by the hardware manufacturer. They are the best. You cannot beat those tools. So for example, we use OpenVINO for Intel-based processors, as well as for OAK-D related projects. And then for NVIDIA, it's TensorRT. for Google also provides tools like this, right? For example, if you want to use the Google tool chain, and some of the models in media pipe are great, right? So you can get things off the bat. You don't even need to do the optimization. It's already done for you. So yeah, so the short answer is that use the tools that are provided by the manufacturer of the hardware on which this is going to run, and dig deep into it, right? OpenVINO, there is one way of optimizing, but if you dig deeper, you will see that there are there are several layers of optimization. It's a whole thing in itself. So if you dig deeper, you will find the one.
Thanks. Yeah. Joseph, you have anything to add to that?
I think all that is exceptionally accurate, and recognizing in addition that there are specific frameworks for the hardware you might be optimizing for. Like we mentioned earlier, OpenVINO for Intel, TensorRT for NVIDIA. There's also model pruning techniques, model quantization to basically reduce the size of the model so that it can run more quickly. So these are some techniques.
Yeah, and we've seen, we've talked about this before, that even running the most basic optimizations for, say, OpenVINO, if you're deploying to a Myriad based product, you get a 2x speed up sometimes for free. So yeah, it's definitely,
and even for your
important.
CPU, not just MediaTek, even on the CPU, you can get that kind of performance boost.
Yeah, good point. Joel has another interesting question. At least I'd like to know the answer to this. What sorts of data does Roboflow support? I mean, is it really focused just on still images? What about video? What about text?
Video for sure. Video and images. We don't yet support text. We're pretty focused on understanding the visual world around us, and there's plenty to tackle and unpack in that realm of things. But all the common file formats you might expect, JPEG, PNG, MP4, these sorts of things. .tiff is actually browser dependent. So if you're in Safari, for example, .tiff will work. But I'd be obviously feel free to shoot me a note if there's a file format you're looking for that you're not seeing as supported.
WebP, what about WebP?
I don't think so.
What about it? Yeah. What about HVEC?
No.
No, so those are things that will come up now, right? I mean, people will want asking for those two specific formats because of they are 30% smaller than JPEG, for example, for the same quality. So
yeah, and the hardware encoding is finally good and relatively performant and stuff. Yeah. Flavia would like to know more about Roboflow.js. This is actually the first I've heard about it too. Would you, in fact, I'd like to learn a little bit more about both OpenCV.js and Roboflow.js. You maybe go first, Satya.
Yeah, OpenCV.js. I mean, you go to OpenCV's repository and you will find that JavaScript. You'll also find some example code there where you use this code in your browser and just put the JavaScript, put the model at some specific location, and you can try, for example, face detection. I remember there are also feature detectors, for example, which you can run inside the browser. So there is a way to convert C++ code into performant JavaScript, and we are using that. It's escaping my mind what exactly it is called, but we use that technique to do it. And similarly, there is TensorFlow.js. People should try out. A lot of these work fine, depending on the application. Obviously, they are not as good as running on the CPU directly, right? Browser is, it limits the amount of processing that's allowed, but still very, very good for many applications. Joseph,
yeah, Joseph, Roboflow.js.
Yeah, Roboflow.js is for running optimized models directly in the browser. And similar to how OpenCV has functionality for running OpenCV algorithms, that's pretty similar. So if you've trained a model with Roboflow, then it becomes automatically optimized to run like a lot of those things we're mentioning around optimizing model size, ensuring that the frame rate is high as possible. And so with Roboflow.js, what you can do is basically pass any canvas element inside a browser to your model, and then you can get inferences streamed live on frame by frame. So you could pass like images or video or things like this. And the other thing you can do with JavaScript and Roboflow is closing the loop. So you can add images back to your Roboflow project where your model is failing. I'll drop a link to the docs. There's both a video of building with a thumbs up, thumbs down detector. What it does is when it detects a thumbs down, it flips the camera, it flips the video feed upside down. So it's kind of a fun demo in the doc.
That is cool. Yeah. Yeah, let's see. We're about coming up on 10 minutes after the hour. Do we want to do one more question and we can call it a day here. Can you, Joseph, first of all, if people want to get in touch with you, what are the best ways to do that?
Happily, via email is great. Me and my team will happily help out. Joseph@roboflow.com. Welcome to, it's my real email, it's direct. Feel free to shoot me a note, very accessible. And then also, of course, there's nothing quite like trying the product out and trying things out at app.roboflow.com if there's any questions there. I'm on Twitter. I'll put my
at Joseph of Iowa.
That's right. You know it.
I've kind of, I'm Pavlovian response to like shake my fist at the screen whenever I see your names pop up. So it's easy to remember.
Yeah.
So yeah, last question here today is about a large scale image annotation. Ronald was asking about a large scale deployment where they've got millions of images. It's developed with TensorFlow/PyTorch. They're considering using Spark to be able to scale it. Do you want to talk about other tools for scaling things with these massive data sets?
That's great. That's great. Ronald, I'd love to learn a bit more specifically because we're thinking a lot about this too, of when you have this many images, selecting down like the most useful images or some things that we're interested in. I think for large scale distributed systems, I highly recommend the O'Reilly book, Designing Data Intensive Applications. I really enjoyed it. I think for images specifically, I think in data science land, Spark certainly is a good place to turn to. I think for us, what we're focused on is if a user is hosting images with us, ensuring that things are performant for loading data directly into a session and then splitting the images out. So you can almost imagine like a SQL for images like interface where you can select and kind of remove that abstraction for users. But ultimately, of course, the systems that you use to determine for scaling up your application for large scale systems depends upon a lot of other factors that I'm sure that Ronald, you have a lot more intel on than I would be able to comment on.
Right on. Yeah, thanks. Do you have anything to add there, Satya?
No, I think Joseph covered it, and I'll have more to add to it in about a month. We are working on a project which has a large data set, and we'll be doing research for that. So I'll have more to say on that. But right now, I think what Joseph mentioned is pretty comprehensive.
Yeah, no substitute for hands-on experience,
Yeah.
Yeah, so I think we're about done here. You want to take us home, Satya?
Yeah.
Oh man. Yeah, you lost your camera there. So I do a little song and dance here, soft shoe, little heel turn. Thanks again for joining us, Joseph. It's always a pleasure.
I want to add one. Oh God,
we lost you again, man.
Let's just. I'll just want to add one more thing. That and this is not like plugging Roboflow, but one thing that people need to be very aware of is when they're building a model, right? Do not forget the data. So data annotation is not done once. Data is cleaning up the data annotation, etc. It's an iterative process. So we always have to. So that's why tools like Roboflow are very useful, because they combine. They don't let you forget that data is a separate system than your training process, right? A lot of times people think that, I annotated the data once and that's it, right? And now I'm going to train. My data never changes. That's a very wrong approach. And some things came up recently because of which I'm bringing this up. But there is a very good, and I did not. We always come up with, when we select a model. We first select a model based on our application, and the way to select it is that can you actually overfit the model on your training set? If you can, then the model has enough capacity to train on your set. And then we don't change the model. Actually, it's not like we are going and changing model architectures and finding the best model architecture. We freeze the model and work on the data, right? We try to make sure that the data is consistently labeled. We try to make sure there is no noise in the data. And this is especially true when you're working with small data sets, right? It is exceptionally, and I did not know the word for this until recently. This is our standard practice. Fortunately, Dr. Andrew Ng has a video called it's data-centric versus model-centric approach. You can find that on YouTube. It's a very useful thing to learn or understand. A lot of people spend a lot of time trying to find the best model that will work for their application without actually doing anything about the data, whereas you get a lot of gains by focusing on the data, not on the model, right? And tools like Roboflow, because everything is in one package, you don't forget that the data is right there. You go and fix the data if it's not performing well, right? So something just from my personal experience, something came up recently where I had to make this pitch very strongly to a client. I just wanted to share it with the community as well.
Yeah, thanks for that. I think we're hitting up on time. In that case, you want to go ahead and take us home, Satya?
Yeah, thank you so much, everybody, for joining. And thank you, Joseph. It's really good to have you again here. Wonderful presentation. Thanks, Phil, for managing this webinar and getting us live on LinkedIn today.
Yeah, maybe next week we'll try to hit up YouTube as well. Our guest next week will be from rephrase.ai. You want to tell us a little bit about our next guest, Satya, what they're kind of known for?
Oh yeah, so next week it would be another interesting episode. We are getting the CEO of rephrase.ai. This is the company that created a very popular ad in India. So during Diwali, which is, let's say, it's like the Christmas in India, it's a popular festival. They got Shah Rukh Khan, who is, let's say, the Tom Cruise of India, right? So they built an AI model that would make Shah Rukh Khan say the name of the local store. So every local store could have their personal ad where this celebrity is endorsing their product. And this was obviously done in collaboration with the celebrity. And Ogilvy is the company, the marketing company that ran this campaign. The technology was provided by
one of the old ones. They've been around for a long, long time.
Yeah, so it's going to be very interesting how they made good use of, they don't like to call it deep fakes, but in some sense.
Well, yeah, it's not a deep fake, it's a deep reel, basically. Because it's like, right. the actor would have done it, but they just would have taken an insane amount of time.
They don't have the scale to do it, right? So now mom and pop shops have advertisements for their for their local shops.
Scaling up personal endorsements is an unexpected use for AI, but it's interesting nonetheless. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision from the experts at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.